Welcome back to our video series on astronomy. I am Mr. Nelms, one of the physics and astronomy teachers here at Haberdashers Adams. Today we're going to look at why, despite the fact that only one side of the moon actually faces us, we can see 59% of the moon's surface from Earth.
3, 2, 1.
We choose to go to the moon.
From the Earth, we can only see one side of the moon, the near side. This is because the moon is tidally locked in its orbit about the Earth. This means that the time taken for it to rotate 360 degrees is the same as the time it takes for it to complete one orbit of the Earth. Because of this, it would be perfectly reasonable to assume that we can only see 50% of the entire lunar surface. However, because of a process called lunar libration, we can actually see an extra 9% of the moon's surface at different times. Now, whilst the whole process is called libration, there are actually 3 different types of it, and they occur in different ways. The first of the 3 types of libration that we're going to look at is the one that happens over the shortest timescale, diurnal, meaning daily, libration. This occurs as a result of the rotation of the Earth, which moves the position of an observer relative to the moon throughout the day. For instance, if in the morning we are viewing the moon from this location, then in the evening we will have rotated around to this position. As the diameter of the Earth is around 12,700 kilometers, this shift in position allows us to see the moon from a different position. As we can see on this ridiculously not-to-scale diagram, the change in position of the observer from morning to the evening allows us to see ever so slightly more of the eastern or western edges of the near side of the moon, depending on when we view it. When placed at the correct distances, this effect allows us to see around 1 degree more of the eastern and western edges of the lunar surface. This is almost impossible to spot with the naked eye and would require a series of very focused photographs on the eastern and western edges of the moon to observe the effect properly. For our second type of libration, we need to consider the shape of the moon's orbit around the Earth. The moon is in an elliptical orbit around the Earth. This gives a variable distance between the Earth and the moon, and also a variable speed to the moon's orbit, with it travelling quicker when the moon is closer to the Earth and slower when it is further away. However, the rotation of the moon on its axis happens at a constant rate, not a variable one. This means that at points in the lunar orbit, the increased orbital speed means that its orbit gets ahead of its rotation, allowing us to see slightly more of one edge of the lunar surface. This effect is seen in the opposite direction half a cycle later, when the moon is orbiting slower than the rotation, which enables us to see more of the other edge of the near side of the moon. Viewing the moon at these 2 points gives us an east to west or longitudinal wobble, which can be much greater than the diurnal libration in amplitude. At its greatest, it allows us to see an extra 7.5 degrees of the lunar surface. Much like with diurnal libration, if you want to observe libration in longitude, a series of photos focusing on the eastern and western limbs will be a great starting point. If you focus on lunar features which are at the very edges of the near side of the moon, like the Mare Crisium, or Sea of Crises for those of us rusty on our Latin, then the movements of these will allow you to see the effect more easily. As you may be aware, the Earth is tilted on its axis, with an angle of 23.5 degrees between its axis and the upright to the plane that it orbits the Sun in. However, the Earth is not the only thing in the solar system that is tilted. the orbit of the Moon about the Earth is tilted by just over 5 degrees compared to the plane that the Earth orbits the Sun in. Add into this that the Moon itself is at an angle of about 1.5 degrees to its own orbital plane, and this means that we are often not looking at the Moon straight on from the Earth. This varies as the Moon completes its orbit, with it sometimes positioned above the Earth's orbital plane, allowing for a greater amount of the southern lunar surface to be seen at some points in the lunar cycle, and more of the northern edge to be visible at others. This allows for around an extra 6.5 degrees to be seen at the very edges of the near side of the Moon, within each orbit of the Moon about the Earth. So you may be thinking, what is the best way to observe these different types of lunar libration? For these, a series of images taken throughout each orbit of the Moon is essential. This will allow you to track libration in longitude and in latitude, especially if you overlay images of the Moon on top of each other, making each image transparent so you can see the turning face of the near side of the Moon and how this allows you to see that extra 9% of its surface from Earth. If you then repeat this over a series of months, it will allow you to get repeats of your data, which in turn allows you to see how these processes link to the various phases of the Moon in its own orbit of the Earth. When observing the Moon for these types of libration, seeing it when it is highest in the sky will lead to better quality observations. This occurs when the Moon crosses the meridian, which is an imaginary line from north to south in the sky, directly above you, the observer. To work out when this happens, I recommend looking up when the Moon rises and sets. There are various websites which will allow you to do this, and this will be unique depending on your longitude on Earth. This is also useful for diurnal libration, as you can look for a day where the Moon is visible for at least 12 hours, which will allow you to take photos with a large time interval between them. As this is the type of libration with the smallest angular change, this can be the hardest to notice. So photography with a decent zoom or use of a telescope may be essential to observe this effect successfully. If you want to look at the Moon's orbit in more detail, then here are 3 questions which you can use to research the topic further. 1. How does the Moon's orbit affect the tides on Earth? 2. Why is the Moon orbiting on a different plane to the Earth's orbit around the Sun? 3. Why might you want to observe the Moon and other celestial objects when they are highest in the sky? As ever, thank you so much for watching this video, and we hope that you have enjoyed the whole lunar series as much as I did when researching and filming for them. We will have some shorter videos on the way whilst we prepare for Series 2, so until then, please continue to watch this space. Thank you.